Hey guys, in this video we'll explain how to perform a one-sample t-test. So if you want to learn the formula, how it compares to the z-test and when to use which, and how to use the t-table as well as with some examples, then keep watching this video and enjoy. First, let's consider all of the relevant formulas. The first formula is for the t-score itself, and it's x bar, which is the sample mean, minus mu, which is the proposed population mean, divided by the standard error of the mean, or Sx bar. Sx bar itself equals to the sample standard deviation, S, divided by square root of the sample size, n. Last but not least, we have the degrees of freedom formula, which is n minus 1. So this is similar to the formula for sample variance. And the purpose of a t-test is to compare two means when the population standard deviation is unknown. Now let's figure out when we use the t-test as opposed to the z-test. The first question we're going to ask is, what is our sample size? In case it is more than 30, it doesn't really matter. We can use either, since the t-test for values of n more than 30 is going to approach the values we get with the z-test. However, if our sample size is smaller than 30, we have to ask the second question. Do we know the population standard deviation? If we do know the population standard deviation, we're better off using the z-test. However, if the population standard deviation is unknown, we are going to use the t-test. Now let's assume that we decided to perform a t-test after all. And at one point or another, if we're not using a fancy calculator or a computer program, we will have to deal with the good old tables. Let's say we're performing a one-tailed test where alpha equals to 0.05. Our sample size is 9, that gives us 8 degrees of freedom, and we have to find the critical value. We first look at the columns until we find the matching value of alpha, and then we find the matching number of degrees of freedom, and at the intersection of those two we have the critical value of 1.8860. And this would be an example of the critical value approach. Now we are free to compare this critical value to our t-statistic. And another thing we could do would be to follow the p-value approach, as we've outlined in our significance video, which you should definitely check out if you haven't watched yet. And we can essentially reverse this. We can look at our t-score and find out the corresponding p-value. Let's take a look at an example. We have the null hypothesis stating that the population mean is less than or equals to 30, and the alternative hypothesis claiming that the population mean is more than 30. We also run some tests, and this is what we get. We have a sample size of 10, the sample standard deviation of 15, and the sample mean of 40. Our hypothesis test is going to be with 95% confidence level, so our alpha equals to 0.05, and as stated in the null, our assumed population mean equals to 30. So this is a one-tailed test, as you may have guessed, and we are given the task of calculating the t-score. In order to calculate the t-score, we have to go back to our formula. We subtract the population mean from our sample mean, and we divide the difference by the standard error of the mean to obtain the t-score of 2.11. And since our sample size equals to 10, we have 9 degrees of freedom. Now, we're going to use both the critical value approach and the p-value approach to draw conclusions about our hypothesis. So first, the critical value approach, and the critical value for the alpha of 0.05 equals to 1.8833. And 1.833 is actually less than 2.11. So this means that our test statistic is higher than the critical value. And that means that we would normally at this point reject the null. However, we're also going to calculate for the p-value approach, and for that we need to find the p-value that corresponds to our t-score. And for the t-score of 2.11, the corresponding p-value is 0.032. So we should now compare the p-value to alpha, and we see that the p-value is indeed less than the alpha, which just confirms our results that we obtained with the critical value approach. So in both cases, we have enough evidence to reject the null and accept the alternative hypothesis. Thank you very much for watching. Hopefully you've enjoyed this video. Either way, leave us your feedback in the comment section below and stay tuned for more.